Welcome to Fun Facts Online. Let's start with a myth. Diamonds are chunks of coal squeezed under immense pressure. It's a great image, but it's completely wrong. The real story is far more incredible. Diamonds are not made from ancient forests, but from carbon forged in the heart of our planet, hundreds, even thousands of kilometers beneath our feet. They are nature's ultimate time capsules, crystalline messengers from a realm we can never visit, the Earth's mantle. Today, we're going to unlock these time capsules and read the secrets they hold about the hidden world within our own planet. Forget jewelry. These are the most valuable scientific artifacts on Earth. So, where do they come from? The journey begins in the mantle, a nearly 3,000-kilometer thick layer of hot, solid rock that makes up 84% of Earth's volume. It's a place of extremes, with temperatures reaching 4,000 degrees Celsius and pressures over 1,000,000 times what we experience on the surface. Although it's solid, on geological timescales the mantle churns like a thick, slow-boiling soup, driving the movement of continents on the surface. Geologists divide this vast layer based on how earthquake waves travel through it. The upper mantle extends down to about 410 kilometers. Most commercial diamonds, the ones you might see in a jewelry store, form in the deepest part of this layer, between 150 and 250 kilometers down. Below that, from 410 to 660 kilometers, is the transition zone. Here, the pressure is so intense that common mantle minerals are crushed into new, denser forms. At 410 kilometers, the mineral olivine transforms into wapsiite. Deeper still, it becomes ringwoodite. These names might sound obscure, but remember them. They hold a planet-changing secret. Finally, below 660 kilometers, we reach the lower mantle, the single largest part of Earth's interior. Here, the minerals change again, forming substances like bridgmanite and ferropericlase, minerals that, for decades, were purely theoretical. We map this structure using seismic tomography, which is like a CT scan of the planet, but it only gives us a blurry, large-scale picture. To get the fine details, we need a direct sample. We need a diamond. So how is a diamond born? Not from coal, but from a process called metasomatism. Carbon-rich fluids, or melts, seep through the solid mantle rock. Through complex chemical reactions, this carbon is freed from its bonds, and, under the right pressure and temperature, crystallizes into the diamond's iconic, ultra-strong structure. The carbon itself has two main origins. Some of it is primordial, left over from the Earth's formation. The rest is recycled carbon. This is carbon that was once on the surface, perhaps as limestone, or even as the remains of ancient microscopic organisms. It gets dragged deep into the mantle when one tectonic plate slides beneath another in a process called subduction. By analyzing the type of carbon, scientists can tell if a diamond's building blocks came from the deep mantle or from the surface. This has led to two main families of diamonds. Peridotitic diamonds, or P-types, form in the most common mantle rock and are usually made of primordial carbon. Eclogitic diamonds, or E-types, form in a rarer rock that geologists believe is the remnant of subducted oceanic crust. These E-type diamonds often contain that recycled surface carbon. For years, this was the whole story. But then, scientists started finding diamonds that broke all the rules. These were the messengers from the true abyss, superdeep diamonds. These rare gems don't form in the relatively shallow 150-kilometer zone. They are born in the tumultuous depths of the transition zone and lower mantle, starting at over 300 kilometers down and sometimes as deep as 800 kilometers or more. They are chemically different, often exceptionally pure and large, like the famous Cullinan diamond. But their most important feature is what they carry inside: microscopic flaws, or inclusions. For a jeweler, a flaw reduces a diamond's value. For a scientist, the flaw is the whole point. These inclusions are perfectly preserved, microscopic samples of the deep mantle, shielded by their indestructible diamond casing. and they have revealed some of our planet's most profound secrets. Perhaps the greatest discovery came in 2014 from a tiny, dirty-looking diamond from Brazil. Scientists analyzed an inclusion inside it and found ringwoodite, that superpressurized mineral from the transition zone. This was the first time anyone had ever seen natural, terrestrial ringwoodite. But the real shock was what it contained: water. Not liquid water, but water chemically bound within the mineral's crystal structure, making up 1.5% of its weight. That might not sound like much, but the transition zone is enormous. If this tiny grain is representative, then this single layer of the mantle could hold as much water as all of the world's oceans combined. This discovery provided the first direct evidence for a wet transition zone, a massive internal reservoir of water that was carried down by subducting plates and plays a critical role in how our planet works. The secrets didn't stop there. The lower mantle, making up over half the planet, was thought to be made mostly of a mineral called bridgemanite. But since bridgemanite is unstable at low pressure, no one thought we'd ever find a natural sample. Again, a super deep diamond provided the answer. Inclusions of bridgemanite were found, perfectly preserved within their diamond prison, confirming our models of the lower mantle were correct. Then, in 2021, another impossible mineral was discovered in a diamond from Botswana, named davemaoite. It's the third most abundant mineral in the lower mantle. Crucially, davemaoite is able to host radioactive elements like uranium and thorium. These elements are the engine of the mantle, generating the heat that drives convection and plate tectonics. Finding davemaoite confirmed that these heat sources exist deep within the planet, solving a key piece of Earth's thermal puzzle. Diamonds have even trapped water in its purest form. In 2018, scientists found inclusions of something called Ice 7. This isn't the ice in your freezer. It's a form of ice that only exists under immense pressure. Finding it proved that at these extreme depths, water exists not just locked in minerals, but as a separate, mobile fluid, a fluid that can trigger melting and help create the very diamonds that trap it. And the discoveries get even stranger. Models predicted that the deepest parts of the mantle should be so reduced, so starved of oxygen, that metallic iron could exist. In 2016, analysis of large, pure diamonds revealed tiny inclusions of a solidified iron-nickel metallic melt, often surrounded by a jacket of methane and hydrogen. This was monumental. It showed that some of the world's biggest and purest diamonds grew from droplets of liquid metal in the deep, convecting mantle, confirming the existence of a metallic realm far above the core. So what does this all mean? These individual discoveries piece together Earth's grand narratives. We now see a deep water cycle, where water from our oceans is dragged hundreds of kilometers down, stored in the transition zone, and then released to influence everything from volcanism to diamond formation. We also see a deep carbon cycle. Diamonds prove that carbon from the surface, including from ancient life, is recycled into the mantle, stored for billions of years, and then returned to us. It's the ultimate planetary recycling system. These tiny stones even confirm the processes of plate tectonics. The chemistry of inclusions is a direct match for oceanic crust that has been shoved into the mantle. A 2023 study even linked the formation of superdeep diamonds to the assembly of the ancient supercontinent Gondwana, showing that these diamonds were forming at the base of the growing landmass, essentially witnessing the birth of a continent from below. But how do these precious messengers get from 800 kilometers deep to the surface? They ride the Kimberlite Express. Kimberlites are a rare and incredibly violent type of volcanic eruption. The magma originates deep in the mantle, is supercharged with gases like carbon dioxide, and rockets to the surface at speeds up to 130 kilometers per hour. This rapid ascent is crucial. It's a geological elevator that brings the diamonds up so fast they don't have time to revert back into common graphite. Any slower, and all the priceless information locked inside would be erased. So the next time you see a diamond, don't just think of it as a gemstone. Think of it as a postcard from the abyss, a time capsule that has traveled hundreds of kilometers on a journey lasting millions or even billions of years, riding an explosive volcanic eruption to the surface. Within its flawless crystal lattice, it carries the secrets of hidden oceans, impossible minerals, and the vast interconnected cycles that make our planet a living, breathing world. Thanks to these brilliant messengers, we are finally beginning to understand the enigmatic heart of our own planet.